So, how do you connect high stakes geopolitics in the freezing Arctic with a problem that you literally have to measure in atoms? Well, we're going to dive into a story that links these vast strategic shipping routes to the microscopic challenge of creating perfectly smooth glass. It's this wild tale of a global partnership that's playing out on two totally different scales. Let's get into it. Our whole story really kicks off with this incredibly powerful statement made right before the full-scale war in Ukraine began, a friendship without limits. I mean, that is a bold claim, signaling a really deep strategic alignment between Russia and China. And look, this phrase isn't just empty political talk. It's actually the key that unlocks the connection between these two seemingly unrelated worlds. But what does a partnership without limits really mean in the real world? I mean, how does that go from being, ink on a document to actual tangible action? To figure that out, we have to follow the trail of their shared interests, from the very top of the world all the way down to the nanoscale. Okay, so let's start big. We're talking global scale. And the first place where this partnership is really taking shape is the Arctic, a region that is fast becoming strategically critical thanks to climate change and its huge untapped resources. So yeah, this is the stage, the playground for their big picture geopolitical moves. For Russia, the Arctic is basically its backyard, holding enormous resources and the absolutely vital Northern Sea route. And for China, which calls itself a near-Arctic state, it's a massive strategic opportunity. And here's the thing. Their goals fit together like puzzle pieces. Think about it. Russia's got the territory and all the resources, but they're hurting for cash and technology, especially after all the Western sanctions. And China? They desperately need to lock down their energy supplies, and they want to build new trade routes, like their Polar Silk Road, which links up perfectly with Russia's Northern Sea route. It is a textbook win-win. Okay, but this whole friendship without limits thing, it's not just about big maps and pipelines. The collaboration is also happening at a scale so small, it'll kind of blow your mind. And this is what I'm talking about. This is the proof right here. We're looking at scans from an atomic force microscope of a glass surface. That one on the left, that's what you get with old-school polishing, a total mess of scratches. And on the right, that's the result from this new joint technique. It is unbelievably smooth. I mean, this is where that big picture partnership gets super, super real. So let's zoom way in, from geopolitics down to the science. We're going to look at a tiny problem that actually has huge implications for the tech that all of us use literally every single day. So here's the problem. When you're making the glass for, say, your phone screen or a high-end TV, even the tiniest little scratches, stuff you could never see with your own eyes, can totally ruin it. You get dead pixels, other defects, and what does that do? It means fewer good screens get made, and that just jacks up the price for everyone. For years, figuring out how to polish glass perfectly without these micro scratches has been a huge headache. And here it is. This is the machine where all the magic happened. It's for a process called ELID polishing, which, get this, stands for Electrolytic In-process Dressing. Yeah, it's a mouthful. Using this machine, the joint Russian-Chinese research team came up with a whole new way to polish glass. And don't let it fool you, it might look like just another grinder, but the real genius here is in the wheel. Here's how it works, and honestly, it's brilliant. Instead of a normal wheel that has gritty stuff already baked into it, they use this special grainless iron wheel. Through electrolysis, a thin film of oxide forms on the wheel. Then, the crazy heat from the grinding itself actually transforms that film, and bam! It creates these super fine abrasive particles. It's basically just a type of iron oxide right there on the spot. And those are the particles that polish the glass to this incredible finish. The researchers had a great way of explaining this. They said to think of that oxide film like a spring. It kind of gently holds those tiny abrasive particles and presses them onto the glass with this perfectly even force. And that's what stops the harsh, deep cuts and scratches you get with normal polishing. And the results? I mean, they're just insane. This new grainless wheel removes material almost 4 times faster than the old way. So it's not just a little bit better, it's a massive leap forward in efficiency. Okay, so it's faster. But is it better? Oh yeah. The final surface is smoothed down to just 2.1 nanometers. To give you some perspective, a single strand of your DNA is about 2.5 nanometers wide. So yeah, we are talking about an almost perfectly smooth surface. So what's the bottom line for us? Well, it means brighter, clearer screens on our devices. This new method lets up to 95% of the light shine through the glass. That's a huge jump compared to other methods. And that means more vibrant displays that, by the way, also use less power. So this is not just some weird experiment in a lab. This has major real-world potential. Okay, so now it's time to put it all together. We've seen the big picture strategy in the Arctic, and we've seen the tiny ground-level innovation in the lab. So how in the world do these two things connect? And the connection is right here, in the people who did the work. The research paper that revealed this breakthrough, it was co-authored by scientists from a couple of universities in China and, you guessed it, a researcher from the South Ural State University in Russia. That is absolutely not a coincidence. It is a perfect, direct example of that scientific cooperation happening right under the umbrella of that bigger strategic partnership. And when you lay it all out on a timeline like this, the picture becomes crystal clear. You see all these high-level political deals and big strategic plans. They basically created the perfect environment for this kind of deep, technical teamwork to happen and to really flourish. The science is literally growing right alongside the politics. It's like the big picture makes the small picture possible. That huge ambition to build a polar Silk Road isn't really separate from the goal of making a perfect, scratch-free piece of glass. They're just two sides of the same coin, right? It's a deep partnership that's all about solving problems and pushing their shared interests forward at every single level. So at the end of the day, this is what that friendship without limits actually looks like on the ground. It's not just about leaders shaking hands or giant treaties or massive construction projects. It's also about scientists, thousands of miles apart, working together on a really fundamental manufacturing problem. And, in doing so, reinforcing those bigger strategic goals with every single nanometer of progress they make. So, you have this partnership that stretches all the way from the Arctic down to the atom. And it shows you just how powerfully grand strategy and ground-level innovation can feed each other. And it really makes you wonder, right? When science and strategy click together this perfectly, what huge global challenge are they going to take on next?